Thanks to Geology for sponsoring today's video. Pretty much anyone that has an interest in space has heard of the asteroid belt, the large belt of asteroids that have fairly stable orbits between Mars and Jupiter. There are hundreds of thousands that we know of, and likely many more still that we haven't discovered yet. However, this is not the only place in the solar system where asteroids are found. In fact, there are high concentrations of asteroids that aren't just gravitationally bound to the Sun, but also to the planets, known as Trojans. These are not moons, they don't orbit around the planets, but rather they follow the orbits of the planets, either just ahead of or trailing behind them in a position known as the planet's Lagrange points. And while we don't have close-up photos of them yet, that will soon change with the launch of NASA's Lucy probe on the 16th of October 2021. I'm Alex McColgan and you're watching Astrum, and today we will look into the Lucy mission, what we know so far about these Trojan asteroids, investigate how they got stuck in the positions they are in, and find out a very interesting characteristic about them that you wouldn't associate with most belt asteroids. I hope by the end of this video to have earned your like and subscription. Firstly, a small definition for an asteroid. Asteroids can be found from around Venus all the way to beyond Pluto. However, as their compositions tend to get quite different depending on their distance from the Sun, it is more common nowadays to only call small solar system objects asteroids if they are roughly within the orbit of Jupiter. Between Jupiter and Neptune, they are called centaurs, and beyond Neptune they are called trans-Neptunian objects, or Kuiper belt objects, named after the other asteroid belt in the solar system. Objects beyond Jupiter are icier than asteroids closer to the Sun, meaning they are more akin to comets. When we talk of Trojans, we are generally talking about the asteroids that share Jupiter's orbit around the Sun. However, some of the other planets also have varying numbers of Trojans. One was recently discovered following Earth. Mars, Uranus and Neptune all have more. Jupiter, being the most massive planet, has by far the most, with the swarms in front of and behind it estimated to have populations comparable in number to the entire asteroid belt, around 1 million asteroids. However, they are harder to observe, so this number may change as studies improve. This is because they are likely smaller in general compared to asteroid belt asteroids, a lot less massive, and are further out, so some scientists think there aren't as many as initially thought. In this video, I will focus on Jupiter's Trojans. The Trojans following Jupiter are trapped in what is known as Lagrange points, namely the L4 and L5 Lagrange points. These are points in space where the pull of the Sun and the pull of the planet are comparable in strength, meaning an object orbiting the Sun that gets too close to these points may end up getting locked in. The L4 point is ahead of the planet and the L5 point is behind. As a side note, not much gets naturally locked into the other Lagrange points, although sometimes they can come in handy for our own artificial satellites. The James Webb Space Telescope, for instance, will utilize Earth's L2 point. This is to allow constant communication with Earth while being far enough away that Earth's bright day and night cycle don't interfere with observations. Back to Jupiter. The objects orbiting ahead of Jupiter are known as the Greeks, and the objects trailing Jupiter are known as Trojans, although they are all classified as Trojans in a broad sense. It would be wrong to think though that all Trojans orbit along the same plane as Jupiter. Some actually have orbital inclinations of up to 40 degrees, way above or below Jupiter. A few of these Trojans are really big. The largest, named 624 Hector, is over 200 kilometers wide. It's so big, it actually has a 12-kilometer wide moon called Scamandrios. While most other Trojans don't quite get that large, the biggest ones all share a naming scheme, all based on names associated with the Trojan legend, like Achilles and Paris. As I mentioned, the really interesting thing about these Trojans is that a lot of them have different compositions to what we are used to seeing on a lot of other asteroids. They seem to be dark orange or red in color, covered in something known as tholins. This is the same substance that gives Pluto its red patches. However, because the Trojans are so small and so distant, there's not much more we know about them. Which is why NASA is imminently due to launch the $1 billion Lucy spacecraft on a huge 12-year journey. It will visit 7 of these bodies, plus a bonus belt asteroid, and image and investigate them up close. Lucy is a really exciting mission. While the shape of it may look different from anything you're used to seeing before, its payload is actually a hybrid of previous successful missions. The onboard camera is a derivative of the one on board New Horizons, and from what we've seen from the Pluto and Arrokoth flybys, we know it can capture some stunning images. Additionally, it has the Ralph spectrometer and infrared imager, again from the New Horizons probe. But New Horizons isn't the only probe it has scientific equipment from. There's an infrared spectrometer on board based on the one that was used on OSIRIS-REx. It also has radio space equipment for determining the mass of the Trojan it approaches. And while it shares a lot of similarities with other NASA missions, there is a big difference too. Namely, compared to New Horizons that was powered by an RTG, this one will have big solar panels, unlike anything seen on a probe before. Jupiter is roughly 5 times further away from the Sun than Earth is, and using current technology, it really is about the maximum range where solar panels can still be used. Even then, these panels have to be huge, each one being 6 meters in diameter. As New Horizons went beyond Jupiter, solar panels weren't a viable option for it. Lucy's trip to the various Trojans will take it on a rather unusual route. It will get 2 gravity assists from the Earth that will help slingshot it towards its first targets. As it passes through the asteroid belt, it will just so happen to be passing by an asteroid called Donald Johanson. It is a C-type or a common carbonaceous asteroid. Next will be another carbonaceous asteroid called Eurybates, this time found in the Greek camp. Scientists are interested in this 60 km wide Trojan because it has a tiny 1 km wide moon called Quetta. Scientists believe Eurybates was once involved in a big collision, and this is the largest fragment of it that remains. Quetta could be a fragment too that ended up in orbit around its bigger neighbour. Ptolemy is the next target, another Greek camp Trojan and 21 kilometers across, but this time it is one of the mysterious P-type reddish asteroids I mentioned earlier. It is believed to be covered in tholins, a bit like Arrokoth, although scientists think the spectra is a bit different, so we'll be interested to know what the difference is when we see it up close. Next is Lucas, a 34 km wide D-type asteroid, the most common Trojan type, again covered in tholins. What's unusual about this one is that it rotates very slowly, only once every 466 hours, and scientists want to see why. The last one in the Greek camp will be Orus, another D-type at 51 km across. It may well also have a moon. After that flyby, Lucy will take the unusual step of swinging back around into the inner solar system, which will allow it to catch up with the Trojan camp. There it only has one target, but this target is actually a binary system called Patroclus and Menicius at 113 kilometers and 104 kilometers across respectively. This spacecraft has set a record for the number of planned targets in one mission, and they seem like very promising targets. Understanding asteroids helps us understand how the solar system formed, as often they are the pristine primordial remnants of the early solar system. Unfortunately, the first one won't be reached until 2025, so we do have a bit of waiting to do, but I'm excited for what's to come, and I hope you will be too. Fingers crossed everything goes well with the launch. Thanks again to Geology for sponsoring today's video. Now, space science requires a lot of work to get right, and the same can be said for the science behind skincare. Geology is a skincare brand aimed at men that uses science to get skincare right just for you. Purchasing it, I found the application process really interesting. They quiz you about what you are looking for from the product and your skin condition so that the formula is personalized for you. I don't often buy skincare products, so this made it less intimidating for me. Their skincare is built around just a handful of powerful, proven ingredients that have been trusted by dermatologists for decades. Ingredients like retinol, niacinamide, and kojic acid that can help with acne, wrinkles, or other blemishes. The reviews speak for themselves. So if you want to treat your skin, I suggest you give this a go. If you use the link in the description and the promo code ASTROM50, you can get 50% off a 30-day trial set. Thanks for watching. If you want to know more about asteroids, check out this collaboration I did with Scott Manley here. A big thanks to all my patrons and members for supporting the channel. If you want to support too, find the links in the description below. All the best and see you next time.